Let's start recording. Good morning, students. So we are doing objective problems now. Yeah, dual nature of matter and radiation. Objective problems we are solving now. Okay. Yeah. So in this, see question number 37 is there now. 36 is over in yesterday's class. Now question number 37 now. So what they have given in question number 37? See, the accelerating voltage of electron gun is 50,000 volt. Then de Broglie wavelength of electron. We know de Broglie wavelength of electron is equal to 12.27 upon root voltage in angstrom. After all calculations, you have this formula. Okay, yeah, voltage, potential difference voltage is given as 50,000 volt. Okay, that means de Broglie wavelength of that electron will become 12.27 upon root of 50,000 in angstrom. You calculation, you do this calculation gives you 0.055 angstroms. Okay, you need to do these calculations. Root 50,000 value you need to find. Root of 50,000 value you need to find. Okay, yeah, root of 50,000 is equal to, I am finding root of 50,000 is 223.6 nana. Substitute here 12.27 by 223.6. You will get this answer. Okay, option 2 is right answer. Clear now? Yes. Next, let us go for 38. Question number 38. 19 students are there. Okay, question number 38. See what they are given. If the mass of neutron given, mass of neutron is given. So mass of neutron is equal to 1.7 into 10 to the power of minus 27 kg is given. Okay, and if mass of a neutron is this much, then de Broglie wavelength of neutron of energy of neutron is given. Energy of neutron is 3 electron volt given. Okay, so de Broglie wavelength, how much they are asking? De Broglie wavelength formula is lambda is equal to h upon momentum, and this momentum can be written as root of 2m mass of the particle into energy of the particle. Yes, you need to substitute the values, but while substituting, this energy is in electron volt. No, it is not the SI unit. So convert it into SI unit. 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. So your total energy will be 3 into 1.6 into 10 to the power of 19 joules. So de Broglie wavelength lambda becomes, H is a Planck's constant, 6.623 or 63 into 10 to the power of minus 34 joule second unit upon root of 2 into mass of neutron, m value given 1.7 into 10 to the power of minus 27 into energy 3 into 1.6 into 10 to the power of minus 19. Clear? Yes. Do all this calculation, you will get the wavelength is equal to, okay, 1.6 into 10 to the power of minus 11 meters. You will get it. Calculation you need to do none these calculations. Okay, yeah, option 2 is right answer. Okay, students, good. Today 24 are there. Very good. Who are there? 24. Akshata, Akanksha, Akash, Bidrali, Chidambar, Jona, Kirti, Navami, Nikita, Paresh, Pooja, Pratiksha, Priya Yadahalli, Priyanka Mummanawar, Prithvi, Sahana, Satish Patil, Shravya, Shivateja, Sidhu, Suprit, Vivek, Kritika. Good, 24. Good. 25. Yeah, good number. Good. So daily join Nana. It is important classes going on. Okay. Yeah. Next question number 39. Question number 39. See, they have given yes. This is important. CBSE students who are there, you need to remember this. And for board students also, not only for NEET and JEE, it is important for board exams also. Previous year question it is. Okay, a proton and alpha particle accelerated through same potential. One is proton, another one is alpha particle. First one is proton. Proton. What is a proton? H11 is a proton. Alpha particle. What is alpha particle? Alpha particle is nothing but helium nucleus. Helium-24. If you remember, if you remove 2 electrons from the helium atom, then it will become an alpha particle. Okay, alpha is always positive particle, remember. Okay, now both are accelerated through same potential difference. Okay, what is the ratio of de Broglie wavelength? We know de Broglie wavelength lambda is equal to h by root 2 mqv. Correct? Yes. Charge into potential difference, mass of the charged particle. Now, because voltage they said same and h value is fixed, 2 value is constant, means lambda is proportional to 1 upon root of mass of charged particle into charge. Get it? Yeah. So what they're asking, ratio of the de Broglie wavelength. Ratio, how you define? First, which particle they're asking? Proton, then alpha particle. Okay. So wavelength of proton upon wavelength of alpha particle is equal to. Okay. This is inversely proportional. No, it will become root of mass of alpha particle, charge of alpha particle upon root of mass of proton into charge of proton. Clear? It can be written as under root of mass of alpha particle, charge of alpha particle by mass of proton into charge of proton. Correct? Yes. So now see, it will be under root of. Can you see this color? Is it okay? I'll take red color. Yeah. Mass of alpha particle. What is the mass of alpha particle? 4 times. It is 4 times. No? Correct? Yeah, it is 4 is there. 4 times of 1 means 4 times of mass of proton into charge of alpha particle is how much? 2 times. So 2 times of charge of proton upon mass of proton into charge of proton. QP cancel, MP cancel. You are having 4 to the 8 means lambda proton by lambda alpha particle is root 8 by 1 means it will be equal to 2 root 2 no, yes 2 root 2 by 1. So this is the ratio 2 root 2 is to 1. Yes, option 2 is there. Perfect answer. Understood, Nana? Very important for your JEE as well as NEET also. And CET also, very important type of questions, and board exams also they will ask Nana for 2 marks question. You need to remember this type of questions. Okay, clear? Next, question number 40. Question number 40 they have given the de Broglie wavelength of atom at absolute temperature is. Okay, so we know de Broglie wavelength of any atom or any element or any moving particle is lambda is equal to h by momentum, and momentum in terms of kinetic energy can be written as root 2m into kinetic energy or energy we can write. Yes, and again because this is a atom, so atoms means gas molecules, atoms you take. So kinetic energy of atoms formula is in terms of temperature 3 by 2 kT Nana. K is here, K is Boltzmann constant. Here K is what? Boltzmann constant. 1.38 into the value is there, no? That Boltzmann constant. No? Substitute here. You will get lambda is equal to h upon root of 2 into mass of atom into kinetic energy is 3 by 2 kT. K is Boltzmann constant. I am repeating. These two cancel. You will get h upon root 3 m kT. Clear? Yes, this is the answer. Remember, this is the formula. It will be useful for you for solving problems also. They will give temperatures. Temperature, different temperatures. Same molecule at different temperatures. They will ask you ratio of the de Broglie wavelength. You need to find. Okay, this is option 2 is right answer. Got it, students? Clear? No? Next. Question number 44. Question number 41. Yeah. 41. De Broglie wavelength associated with electron revolving around the nucleus in hydrogen atom in ground state. Yes. Important question for your competitive exams. Means like JEE and NEET. Very important question, Nana. See concept, how they are asking. De Broglie wavelength of an electron. See, they have given the particle is electron. Okay. Revolving around the nucleus in ground state. Okay. So this is the nucleus and electron is rotating around the nucleus in particular orbit. This is the ground state, n is equal to 1. Okay. Now we know de Broglie wavelength lambda is equal to h upon root 2m into kinetic energy. Correct? Yes. Or energy we can say. H upon root 2m into energy. Clear? Yeah. So here they are mentioning that it is a alpha particle. This is electron. Here electron is there. Yes, it is a electron. This is the nucleus. Means mass of electron we know. Mass of electron we know. Mass of electron is equal to 9.1 into 10 to the power of minus 31 kgs we know. Now the thing for finding lambda, we need to know E. What is E? They are mentioning that it is rotating in hydrogen atom, that to ground state. We know in ground state hydrogen atom energy is equal to 13.6 electron volt. Correct? Minus sign, minus 13.6 electron volt. This is the energy. Are you understanding, Nana? Yes. Means here is to substitute in that values. Means lambda is equal to h upon root 2 into 9.1 into 10 to the power of minus 31 into 13.6 electron volt. 13.6 into 1 electron volt is equal to 1.6 into 10 to the power of minus 19 joules. Nana. You need to remember that. You need to write the SI unit only always. So 13.6 into 1.6 into 10 to the power of minus 19. You keep do calculation, you will get the lambda value. Okay, you will get lambda value. Lambda value comes to be 3.3 angstroms. From this you will get lambda value is 3.3 angstrom. Okay, here h value also you need to remember 6.63 into 10 to the power of minus 34. This many calculations you should do. Okay, otherwise another method also is there. Let us see that method also. What they are saying, this is an electron. Is for electron a shortcut formula is there for us. What is that shortcut formula, Nana? Yeah, so de Broglie wavelength of electron is equal to 12.27 by root V in angstrom. Correct? Yeah. So just if you know V value, it will become short calculations. Calculation will become somewhat easy. So potential we need. Okay. See here, as we know that kinetic energy is equal to EV. Correct? Yes, work done is equal to kinetic energy. So kinetic energy, work done can be written as charge into voltage. Yeah. So kinetic energy of electron rotating in a ground state of the hydrogen atom is how much? 13.6 electron volt. Yes, 13.6 electron volt is equal to EV. E cancel. So voltage how much you got? 13.6 volt. You got. Okay. Just substitute here. 12.27 upon root of 13.6. You'll get answer in angstrom. So 12.27 by root 13.6 value I want. Okay, I am checking in Galaxy Nana. Root of 13.6 value is 3.68. That is 3.6878 almost. So equal to how much? You need to do 12.27 upon 3.6878. It comes out to be 3.327 angstrom, means nearly equal to 3.3. Yes, angstrom. Correct? Yes, option is there, option 2. However, it will strike you like that you solve the problem, but make sure that it should be a short method. If you remember, whenever they will give for electron, instantly you should remember this formula. Whenever electron is given, you should remember this formula. So you should get the value of voltage. If you are not getting the value of voltage, then first method is preferable. Here we can get the value of voltage because kinetic energy we know in ground state, or energy we know in ground state. That is the result. Got it, students? I hope you are understanding clearly. Okay? Yeah. 41 is over. Now let us go to 42. Question number 42. Okay. Question number 42. What they have given? See. Question number 42. The wavelength of very fast moving electron. See, they are giving that very fast moving electron. So velocity of that electron is almost nearly equal to velocity of light. Relativistic mechanics you should use, Nana, here. Okay, yeah. So we know wavelength lambda is equal to what na? H by momentum, that is nothing but mass into velocity. When a particle is moving with a very large velocity, then mass of that particle can be written as m naught upon root of 1 minus v square by c square. Clear? Okay, yeah, this is the how mass will change with respect to velocity. See, if velocity is almost equal to velocity of light, v and c both are equal, this thing cancel, 1 minus 1 is 0, anything by 0 means infinity, means mass will become infinite. Okay, see, if you are moving, if you move with more than means nearly equal to velocity of light, 3 into 10 to the power of 8 meter per second, then you will feel you are having infinite weight. This is the reason. Okay, that means substitute there, you will get lambda is equal to h upon m naught, m value what na? M naught by root of 1 minus v square by c square into v. Clear? Yes, it will become h, this total value go to numerator, means h into root of 1 minus v square by c square upon m naught v. Yes, search for that option. Yes, option 4 is there, h into root of 1 minus v square by c square into m naught v. Yes, option 4 is there. Got it, students? Clear? Okay, 42 is option 4. Next, 43. Which experiment explains the wave nature of electron? See, Davison and German, they have done one experiment. Okay, that experiment proved the wave nature of electron. Particle nature of electron is proved by photoelectric effect. Wave nature is by Davison German experiment. Very important. Okay, yeah, 43, option 2. Next, 44, question number 44. Question number 44. What they have given? See, in Davison and German experiment, the filament emits. Filament, what it will emit? Filament emits electron. Nana. See here, I told you that here one electron gun will be there like this. Okay, and here small hole will be there, and here nickel crystal will be there. Okay, so these electrons, they will hit this nickel crystal and they will scatter in all direction like this. Okay, here one rotating frame will be there. Rotating frame will be there. While explaining, I have explained. This rotating frame will rotate like this, and it will collect these scattered electrons for different angles. We have drawn the graph between intensity of light and scattered electron angle, this phi angle. Okay, so it means what are the electrons which are ejecting from the electron gun is electrons. Okay, they are not photons, not energy particles, they are electrons. Remember, okay, they are not the photons, they are not photons also, they are not x-rays, they are electrons. Remember the point. Okay, next, the curved curve representing the intensity of scattered intensity I and phase difference phi in Davison experiment is option 1 is right answer. See here, when this is here, this side scattering electron will be more. When it will come here like this, it will become maximum at one particular angle. Then with increasing angle, this side scattering electron will be less. Common sense use. Okay, means with increasing angle, scattering decreases. Again, this side increases again. Means first intensity of scattered beam increases, reaches the maximum value, and then decreases. Okay, here only this option is here. Remaining all, first intensity is more, then it is decreasing. No, first it will increase. So this is wrong. This is also wrong. This is also wrong. Option 1 is right answer. Remember this type of graphs. Graphs are important for competitive exams. 45, option 1 is right answer. Next, go to 46. All are for Davison German experiment only. Okay. 46. What they are given in Davison German experiment? Nickel crystal acts as. Nickel crystal is used, Nana. Just now I told you. It acts as a three-dimensional diffraction grating. X-ray diffraction you have done in chemistry. There we will discuss. Okay, it will be a three-dimensional diffracting grating. It will be acting like this, Nana. Remember this name. Okay, it is not an observer, it is not a reflector, it is not a two-dimensional refraction, it is a three-dimensional. 3D, it will three-dimensionally it will scatter the electron. All the direction it will scatter the electron. It won't scatter the electron only in one particular plane. It will scatter in all directions throughout the space. Okay, so that's why three-dimensional is important word. Next, diffraction waves in German, Davidson and German experiments are, what are the diffracted waves? Electrons are the diffracted waves. So the electrons from the electron gun, they will fall on the nickel crystal and they will diffract. So diffracted waves are the electrons only. They are not the photons or protons. Okay, they are not the photons and X-rays. They are only the electrons. Remember the name. Okay, na? Clear, na? Okay, next question number 48. Let us go for question number 48. What they have given? See. Question number 48. An electron and proton have same de Broglie wavelength. Yes, electron and proton both are having same de Broglie wavelength. Wavelength is same. Okay. Then kinetic energy of electron is. What about kinetic energy of electron? Yes. So de Broglie wavelength of electron is equal to de Broglie wavelength of what? Proton. They are given electron means -10. Proton means H11. Okay, mass of electron means charge of both one will be 1 only, whereas mass of electron is 9.1 into 10 to the power of -31 kg. Mass of proton is 1.67 into 10 to the power of -27 kgs. You know this. Okay. De Broglie wavelength formula we know. Lambda is equal to h by root 2m kinetic energy. Correct? Yes. I am writing h by root of 2 times of mass of electron into kinetic energy of electron is equal to h upon root of 2 times of mass of proton into kinetic energy of proton. H's cancel, root cancel. You can write 2 also cancel. You can write mass of electron into kinetic energy of electron is equal to mass of proton into kinetic energy of proton. What they're asking? They're asking kinetic energy of electron. So let us take kinetic energy of electron is equal to mass of proton by mass of electron into kinetic energy of proton. Okay. What is the ratio of MP by MB? MP is more than MB. Means it is greater than 1. Okay. MP by ME is greater than 1. Yes. Because this is more 27. It is 31. -31. Very less. Okay. That means we can say that kinetic energy of electron is, because it is greater than kinetic energy of proton. Yes. So greater than the kinetic energy of proton. Yes. Option 4 is right answer. Student, got it? Clear? Understood? No? Concept is important. Though it is oral question, but it is important concept. Okay. Next, question number 49. De Broglie equation for electron shows what? De Broglie equation for electron shows what? De Broglie equation what? Lambda is equal to h by mv. This is de Broglie equation for electron. Okay. De Broglie wavelength of electron is what? H into root of 2 into mass of electron into charge of electron into or kinetic energy. I'll write. Okay. Kinetic energy. Or 2me, no, kinetic energy. Okay, kinetic energy. Okay. That means it is having a relation between mass and wavelength. Lambda means wavelength. Here mass means it is showing either of one, means wave nature it is showing and particle nature also it is showing. That means it is shows dual nature. De Broglie wave equation gives you dual nature. Okay, it doesn't gives you particle nature alone. It doesn't gives you wave nature alone. It gives you dual nature number. 49. Option 3 is right answer. Okay, don't get confused. Photoelectric effect gives what? Photoelectric effect gives what? Photoelectric effect gives particle nature. Interference and diffraction gives wave nature. Got it? Question number 51. 50. Question number 50. What they have given? See there. What will happen to de Broglie wavelength if the velocity of electron is increased? Simple. De Broglie wavelength lambda is equal to h by mv. Okay. If velocity is increased, de Broglie wavelength will decrease. What is there in this? Direct question. It will decrease. Okay. Clear? Next. 51. A proton of wavelength 4400 angstrom is passing through vacuum. Okay. The effective mass and momentum of the photon is for JE and NEET. So photon having a wavelength they have given. How much Nana? 4400 angstrom. Okay. What they're asking? What is the mass of that photon and what is the momentum of that photon? They're asking. Okay, let us find. Okay. First we know that according to de Broglie, wavelength lambda is equal to h by p. That means momentum p is equal to h by lambda. Correct? Yes, we know. So momentum p is equal to h value 6.63 into 10 to the power of minus 34 by wavelength lambda given 4400 angstrom. Angstrom is nothing but 10 to the power of minus 10 meters. Keep the value when you are substituting in units SI unit. Okay, so it will be 44 into 10 to the power of minus 8. Correct? Yes, because of these two zeros, it will become minus 8. Okay, yeah. So 44 into 10 to the power of minus 8. It comes out to be how much? I am calculating the line. Okay, yeah. So 6.63 divided by 44, how much? 44 is equal to 0.15. Okay, 0.1506 you are getting into 10 to the power of minus 34 plus this is minus 34. This minus side going to the upside, it will become plus. So plus 8, how much? 10 to the power of minus 26. Okay. So momentum is 0.15 into 10 to the power of minus 26. Momentum unit what? Kg meter per second. This is the momentum. Okay. So option is there. C. Option is in momentum kg meter per second is 1.5 is there. Okay. So it will be 0.15 is there. Means it will be 1.5. You can write no. Yes. One point you bring this side, one division. It will become how much? 10 to the power of minus 27 kg meter per second. Yes. Momentum is this much. Option 1 is there. Option 2 also is there. But we need to find mass also, no? Yeah. So for finding mass, we know that a particle is moving with velocity of light. Momentum p is nothing but mass into velocity. Correct? Yes. Because this is what? A photon. Photon always moves with a velocity of light c. That's why I'm using mv in the place of mv. I'm using mc. Okay. So then mass is equal to what? P by c. P just now I got 1.5 into 10 to the power of minus 27. C value we know 3 into 10 to the power of 8. Correct? Yes. 3 ones are 3. 3 0.5 are. Clear? It is 0.5 into 10 to the power of minus 27. My plus 8 is there going to that side. It will become plus minus 8. Minus 27 minus 8 is minus 30. How much? 27 plus 8. How much, Nana? 27 plus 8, how much? 35, correct? Kgs. 0.5 into 10 to the power of 35. Means it can be written as 5 into 10 to the power of minus 36 s kgs. Option C there now. Done. Option C, option 5 into 10 to the power of minus 36. Yes, option 1 is there. Got it? How to calculate? You understood now, students? Okay, na? Clear? Next. 51 is over. Next 52. Which of the following is true for photon? Which of the following is true for photon? We know that energy of photon is equal to hc by lambda. Yes, this is perfect. Kinetic energy of photon is not half mv square. Nana. Wrong. Because it is moving with velocity of light. And momentum p is equal to e by 2v. Wrong. Kinetic energy half mc square is also wrong. Total energy. Total energy can be written as p into c. Means nothing but mc square we can write total energy, not half mv square. Half mv square is wrong. Means first option is right answer. Okay, energy of photon can be written as hc by lambda. Yes, first option is right. Clear, students? Next, question number 53. For a moving particle having yes, Nana. Question number 53. Question number 53, they are given that for a moving particle having kinetic energy E, correct de Broglie wavelength is okay. So correct de Broglie wavelength what? Okay, for a moving particle, correct de Broglie wavelength. It is not applicable for a particle. No, it is applicable for all the particles which are moving. Next, they have given that lambda is equal to h by root 2 me. Yes, it is correct. E into root h by 2m is wrong. H by 2m. It is direct formula. Na? Okay, 53 is direct formula. Option 2. Next, question number 54. Question number 54. They are given that de Broglie wavelength of electron in the first orbit is okay. So we know that according to de Broglie equation. So when electron is rotating, see this is the nucleus. Around the nucleus, electron is rotating. When electron is rotating like this, it will move in the form of like this. Okay. As we know that second postulate of electron, that is MVR, angular momentum MVR is equal to NH by 2 pi. Correct? Yes, we know this. Angular momentum of electron in a stationary orbit is equal to MVR is equal to NH by 2 pi. Clear? Yeah. So from this MV you send this side, 2 pi send that side. You will get 2 pi R is equal to NH by MV. Correct? Yes. Means 2 pi R can be written as N into what is H by MV is nothing but lambda. H by P is nothing but lambda. Lambda is equal to H by P. No. Yes. Means they have given that de Broglie wavelength of electron in the first orbit. N is equal to 1 keep. N is equal to 1 keep. It will become lambda will become 2 pi r. Means de Broglie wavelength becomes simply circumference of that orbit. This orbit circumference how much, that much de Broglie wavelength will be there. Okay, equal to circumference of first orbit. Yes, option 1 is right answer, and it is an important question. CBSE students, important. Are you understanding what I am saying, students? Okay. Clear? 54. Option 1 is right answer. Remember, Nana, this type of questions. Next. 54 is over. 55. Question number 55. Yeah, what they are given? See there. Question number 55. If given particles are moving with the same velocities, then maximum de Broglie wavelength is. So if all the particles are given these particles, proton, alpha particle, neutron, beta particle, means electron, all are moving with same velocity, then the maximum de Broglie wavelength, de Broglie wavelength lambda is equal to h by mv. Velocity is same, means lambda is inversely proportional to mass. So if lambda to be maximum means mass should be less. Among proton, alpha particle, neutron and beta particle, minimum mass is for electron. So electron is right answer. Among all the four which are moving with same velocity, maximum de Broglie is wavelength for which particle? Maximum wavelength is for beta particle. If they'll ask minimum, means mass should be more. Mass will be more for alpha particle, na? Minimum means alpha particle, maximum means beta particle here. Got it, students? Clear? Next, 56. Question number 56. A proton is about 1840 times heavier than the electron. Okay, means mass of proton is equal to 1840 times of mass of electron. This is a known factor, we know this. Okay, next. What is the accelerated when it is means a proton is accelerated by a potential difference of 1 electron volt, 1 kilovolt. Potential difference is equal to how much? 1 kilovolt. Then what is the kinetic energy? Kinetic energy of this proton, we know that kinetic energy is nothing but E V naught, potential difference. Okay, E into kinetic energy is given in 1 kilovolt. So it will be 1 kilo electron volt. Answer. Kinetic energy will be 1 kilo electron volt. Yes. Option 3 is right answer. Okay. Important. It may confuse you. Potential difference is 1 electron volt. 1 kilovolt given. Then kinetic energy what? Kinetic energy, we know kinetic energy is equal to charge into potential difference. Potential difference is 1 kilovolt into charge you multiply. So multiply these two, you will get 1 kilovolt into electron is 1 kilo electron volt. Yes, option 3 is right answer. Okay, don't misunderstand this type of questions, Nana. It may confuse you. They may confuse you. Okay. Next, 57. If proton and photon, see, question is important. One is proton, sorry. If electron and photon, one is electron, another one is photon, propagate with the same wavelength, it implies that they can have same, means wavelength of electron is equal to wavelength of photon. They are saying photon it is, okay, not proton. Okay, then what happens? Wavelength is nothing but lambda is equal to h by p, means h by p of electron is equal to h by p of photon. Whereas HH is same, they will cancel. Means that implies momentum of electron should be equal to momentum of photon. Clear? Means it implies that they can have same what? Same momentum they can have. Got it? 57th question. Next, question number 58. Question number 58, they are given that according to de Broglie, wavelength of electron in second orbit is 10 to the power of -9 meters. See, important again. According to de Broglie, wavelength of electron in second orbit. Which orbit? Second orbit is this much. Then what is the circumference? We know circumference 2 pi r is equal to n lambda. Clear? Yes. 2 pi r into second orbit they are given is 2 into lambda given. Wavelength of electron